describe the transformations. So I know that some of you are using graphing to double check your answers. That is awesome. But you can figure this out directly from the equation itself. So if x squared is the parent function, I have to identify what this plus 3 means. Grayson, can you tell me what the plus 3 inside that parentheses means? What type of transformation it is? Yep. And where are we going? Good. So horizontal, and you can either say translation or you can say shift, whichever one. 3 units left. Notice that I'm not putting -3. Okay. These are going to be positive. So it's 3 units left. Okay. And then I also have this -3 on the outside. And Brom, what's that telling us?
3 units down.
Okay, and that is what type of transformation? Good. Yeah, Vanessa? Oh, thank you. And the vertical. And again, you can say translation or shift, but it's 3 units down. Okay, don't put -3. Okay, great. All right. For number 2, you have that negative in front. So remember, the negative tells you that there's what type of transformation? Reflection. And because it's on the outside, it's a reflection over. Good. Okay. If the negative was here in front of the x, that's when it would be a y. So if you had a negative directly on the x, that's when it would be a y. So that's the first thing. Now the 3 means that there is a vertical stretch. Again, it's vertical because the 3's on the outside. So a vertical stretch by a factor of 3, not -3. Okay, the negative goes with the reflection. Okay, and finally, a horizontal shift 2 units to the right. So if it's inside the parentheses, okay, this is a +2, that's your h value is 2, so you're going to the right. Okay, this is your reflection. Okay, and then the 3 is going to be the vertical stretch. Okay, if it was horizontal, do you guys know what that would look like for this? So if it was horizontal, what would we see? Where would it go? Yeah, bigger.
Wouldn't it be -1/3?
That it would you would only take the 3 if the negative was a reflection over the y-axis, but good. It would be the reciprocal and it would be inside the parentheses. So you'd have 1/3 x. Okay. All right. So for number 3, this 1/4 is outside. That means you're going to have a vertical compression. By a factor of 1/4. And then the +1 on the outside means you have a vertical shift 1 unit up. Okay. And then again, if this was horizontal, let's say if you had a horizontal stretch or compression, it would be inside. So if you had 1/4 x squared like this, okay, this is an example of a horizontal stretch by a factor of 4. Okay, and I'm not sure if you guys remember, but when we went over our quiz, we had something similar to that. Okay? So it's inside and you take the reciprocal. So that's the difference between the vertical and the horizontal. Okay? All right, and then use the description to write the quadratic function in vertex form. So you're taking f of x equals x squared. It is vertically stretched by a factor of 4. So to do the vertical stretch, that is going to be 4 times your f of x. Okay, so if I do that, I have 4 times, they even put that in like the parentheses for you, so it'll be 4 times x squared. Okay, and then translated 4 units left. Okay, so if it's translated 4 units left, you will have, this says g of x equals, 4 goes on the outside from before, and then the 4 units left, is that going to be plus or minus inside? Plus. Okay, because the 4 units left is f of x plus 4, so you substitute that into the equation. How'd that one go? All right, good. All right, so 5 is reflected across the x-axis and then translated 3 units up to create g of x. Okay, so again, what I like to do is I identify. So if it's across the x-axis, then I like to write out what my pattern is, the negative f of x. So I know that this is going to be negative x squared for my first step. Then for my second step, it's translated 3 units up. So I know from there that's going to be f of x plus 3 added to the outside. Okay, so this is to create g of x. So g of x just equals negative x squared plus 3. If you kept the parentheses on it, that's not a big deal. You just don't need to. Okay, and then if this is reflected across the x-axis, I just want to show you an example if it was reflected across the y. So let's say instead it was reflected across the y-axis. Okay, then it would look like this. Negative x squared. It would be inside there. Yeah, you would. You'd want to keep it like that. The simplified version would be negative x times negative x, so it would be x squared when you simplified. But these you don't have to simplify, like you don't have to simplify this part here. Yep, good. All right, so for each of these functions, you had to say whether it was upward, downward, the axis of symmetry, the vertex, and then the y-intercept. Okay, so we're going to go through these together. Make this a little faster. I'm going to show you like my work that I did for the first one. Okay, so for 6, it's going to be upward. That's because your a value is positive. For B, make sure you put x equals. I noticed a couple people forgot that. So for the axis of symmetry, you are going to do the opposite of, for axis of symmetry, you're going to do the opposite of B over 2a. So for that one, you'll have the opposite of negative 6 is 6, 2 times 1. That's how you get your x equals 3. Okay, so upward or downward depends on your a value. Okay, so you're going to look at your a value. For B, that's when you use the opposite of B over 2a. For C, you should have 3, negative 4. You are going to plug 3 into your original equation, and that is the work that you see that I wrote over here. Okay, so for part A, look at the a value. For part B, you do x equals the opposite of B over 2a. For part C, you're going to plug in x to find y. Okay, so that's how you get 3, negative 4. And then your y-intercept, that's your C value. So I have 5 here, so your coordinate is 0, 5. Okay, for the graphing part, what I would do is I would use the table on my graphing calculator, and I would put my vertex in the middle. Okay, and then from there, x squared minus 6x plus 5. Okay, so if I go to my table, I'm going to go to 3 because that's right in the middle. And then I can go 1, 0, 2, negative 3, 3, negative 4, 4, negative 3, 5, 0. Okay, so plot those, put your axis of symmetry, and then your part F, your range, I have down here. This is going to be y such that y is greater than or equal to negative 4. Okay, questions for me on number 6? All right, let's check number 7. So 7a is downward. Your axis of symmetry is x equals negative 1, c is negative 1, negative 2, d is 0, negative 3, and then e, you should have a downward facing parabola. The vertex is at negative 1, negative 2. You can see my chart right here. And then the range is y such that y is less than or equal to negative 2. Okay, thumbs up if that went well, thumbs down if we have a question and you want me to go over it more. Some of you aren't giving me your thumbs. All right, and then for 8, A is upward, B is x equals 2, C is 2, negative 4, D is 0, 0. Okay, and then here is my XY chart on the side. Again, I just put my vertex in the middle, 2 up, 2 down. Use our graphing calculator to find the table, put in my axis of symmetry, and then once I see that it's opening up, I know all the points are above the y value. Okay, so on the side here, you can see I wrote out what to do for each step. So if you want a little reminder, feel free to write that. Okay, so for A, you just have to determine if A is positive, it's opening upward. If it's negative, it's opening downward. For B, x equals the opposite of B over 2A. It's a line, that's why you have to have x equals. Okay, for C, you're going to use x from part B, plug it in to find your vertex, your xy. Bless you. Okay, make sure you know how to do all that without a calculator. Okay, because you're going to have to show your work for those. You're going to have to show me that you know how to do these steps here. Okay, D, the y-intercept is your C value, or you can just plug in 0 for x. Okay, it's really quick to just look at your C value, right? Negative 3. If you don't have a value out here, it's just 0. And then for your range, if it's opening upward, make sure that in your set builder notation, you have the y is greater than or equal to k. Here you have the y is less than or equal to k. But you have to tell me what k is. I think there were just a couple people that put like k on their quiz or your test. The k is the y coordinate of your vertex. Okay? Which I also wrote there. And I'll post this as well, so don't worry if you didn't get it all down. Okay, you'll have a chance to do that. All right, let's flip it over. So for the next